What's the answer?
15000.
So this whole thing is for after collision, and this whole thing is for before collision. Okay, so we will apply the law of conservation of momentum, which states that before collision momentum is equals to after collision momentum. So we will put this value over here, and whatever the equation I have got for after collision over here. So this will become minus 0.15 V plus 5,000, 15,000. So can you get the value of this V, which is representing the speed of the ball from this equation now? Yes,
Yeah,
get the value quickly.
of this V that's with 0.1 minus 0.1215, right?
1600?
No, I'm saying the V that's with the negative
How
0.15.
you will get the value of V from this equation?
Oh, okay, wait. I'll get it right now.
Before that, just make sure that you have calculated this thing correctly. Is it correct?
Which one?
This thing, 16, is it 16,000.25 or 1600.25?
Wait, let me see.
Okay, let me check. Wait a second. That is 162.5. Okay.
Okay.
Okay, now do the calculation quickly.
The answer is gonna be negative, right? The answer will be negative.
Have you done like this? 1600, 2.5 minus 15,000?
Will the answer be, yeah, I did, but will the answer
And
be
then
negative?
the answer after subtraction you have got will be divided by minus 0.15.
But um,
How you have done this calculation? Quickly tell me.
it will be negative because we have to take it to the other side so we can divide it.
Divide by what?
0.15.
So you'll get a negative velocity, okay? And you
Yeah.
will get a negative velocity. Why? Because it is moving in the opposite direction. Clear?
Okay.
Okay. Just give me a second. Okay, done. Any confusion?
No.
Okay. This is the first case of momentum in which the two objects, when they collide, one will move in the opposite direction, the other will move in the opposite direction. What if the two objects, when they collide, let's say they are not colliding, let's say this object is in this direction and this object is in this direction. For suppose m1 is 20 kg and let's say m2 is 3 kg. m1 was moving with a velocity of 2 meter per second and m2 was moving with a velocity of 3 meter per second. Okay. After the collision, they stick together and move combinedly with one velocity. And I want you to find out this velocity. Now, how you will do this type of question? Your first task is to first of all calculate the before collision momentum. Then your second task will be to calculate the after collision momentum. And then apply the formula before collision is equals to after collision. And with the help of this equation, you can get this unknown velocity. So can you do it for me? The data is given to you. Just do it. They stick together and they will combinedly move with one velocity that is supposed to be find out. So you have to find out that velocity. How you will do it?
Um,
This is the second case, okay?
yes. I'll find out the mass and velocity before collision, and I'll find it, and then I'll
You will
find
find
after
the
collision.
momentum. You will find the momentum before collision, okay? For both 1 and 2, okay?
Yeah, okay. I'll try it. I have to do the same thing we did in the last question, right?
Yes. So what is the answer of before collision?
Which is 20 by 2 is 40.
Okay. Then
Uh,
for the second one,
it's 9.
it's 9. So for before collision, what will be the total momentum you have got?
Before collision, it's wait. I have to add them, right?
Yes, yes. So you'll do like this.
49.
It's 49 Newton second. Okay. Be careful that you are supposed to write down the unit with the answers. Otherwise, your answer will not be acceptable. Okay. Now, what you will do in after collision?
I will do the
Because they stick together. So that means they are basically now one object that is moving with a combined velocity v, which is not known. So how you will find out the mass and how you will find out what will be the velocity?
You will combine the masses of the
Yes,
initial
you will
and
combine the masses and then that means 20 plus 3. And
20.
because they are moving with the same velocity, so that velocity we need to find out, which is unknown. Clear? So this becomes 23v. Clear?
Yes.
So apply this now law. Before collision momentum is equals to after collision. What is after collision? It is 23v. And what is before?
49
It is
49
49.
equals
So you will
23
get the velocity. Okay?
Yes.
Did you get it now? Check it out, the answer.
Okay. It's 2.086. So 2.1.
2.08. Okay?
Yeah.
Whatever the answer you are getting, just write it as it is. No need to round off the value. Okay?
Oh, okay.
They'll check your answer, they'll check your calculation, and whatever the answer you are getting without rounding off will also be acceptable. Clear?
If I round it off, will they give me the mark?
They will give you the marks, but sometimes what will happen that let's say they'll ask to calculate the kinetic energy as well for this. Okay? So when you will put this mass velocity formula and you will put the rounded off value over here, you will get a wrong answer of kinetic energy, which is not acceptable. That's why do not round off the value. Okay?
Okay.
Sometimes in the connected part like this, that if this velocity will be used in the next part, then the rounding off values is not feasible. So it's better to stop your answer without rounding off and show your calculations properly. Okay? But if for suppose if this is the final question that they are asking to calculate the combined velocity and there is no connected numerical part, then it's your choice to round it off or just keep it as it is. Okay?
Yes. Okay.
Is that clear?
Yeah.
Okay, the next thing that we have is the formulas of momentum. The change in momentum, this change in momentum, that is mass into change in velocity, if it gets divided by the time, then you'll get the formula of resultant force. One formula that we have studied of resultant force is mass into acceleration. But when a momentum type of question come, use this formula. Force is equals to mass change in velocity divided by time. So this is change in momentum. This change in momentum is also known as impulse. Okay?
Okay.
The greater the force is, like this punch and this punch, the greater the force is, the greater will be the change in momentum and lesser will be the time. The lesser the force is, the lesser will be the change in momentum or impulse and greater will be the impact time. Okay? The effect
Yes.
of collision will be slow if the time increases and the force decreases. Okay? The effect of accident or collision will be more if the force is more and the time is less. Clear?
Yes.
Okay. Then we have turning effect of forces. Do you remember turning effect of forces? A force that is acting that is covering a perpendicular distance till the pivot point or the turning point. Let's say if I'm tightening up the nut with the help of this spanner, this point is known as the pivot point. The force
Yes.
is either moving up or down 20 Newton. So the distance of this force with this pivot point is always supposed to be perpendicular. If it is perpendicular, then the turning effect of forces will be produced, which is also known as movement. not momentum. Okay. So its formula is force multiplied by perpendicular distance. The formula of momentum is force multiplied by perpendicular distance. Clear?
Yes.
Let's say if a bar is given, okay, this is the force which is for suppose 20 Newton, and this is the pivot point. It's not necessary that pivot point is always at the center. It can be anywhere. Okay.
Yes.
How I will calculate the moment? It's simply 20 multiplied by 3 because this force is producing a clockwise movement over here. Clear?
Yes.
Any confusion?
No.
Okay. If I'm saying
I can't hear you.
the mass of the bar is 20 gram, I was not speaking actually, I was writing the question. The mass of the bar is for suppose 20 gram and it is 2 meter from the pivot point. Okay, let's say this is the figure. First of all, they are saying the mass of the bar. So what do you think, where will be the mass of the bar acting? I don't know the position of the force over here, but they gave me the information that the mass of the bar is 20 grams. So on this bar, where will be the mass of the bar acting?
Uh, it will be down,
Where down? Which side?
right,
Left side, right
right,
side, where?
right,
Sorry?
right.
The mass of the bar. Always remember that whenever they are asking for a rectangular bar, okay, for the definite shape of objects like triangle, rectangle, square, the geometric center is actually the center of gravity point where the whole weight or the mass of the object acts. Circle. Clear?
Yes.
So if I'm saying the mass of the bar, that means they are asking for the center of gravity point. This is the center of gravity point. Here the mass of the bar will be acting. But because in the formula of movement, we required force. So we will not put mass over here. First of all, we will convert this into kilogram. So that will become 20 divided by 1000. So it will become 0.02 kg. Because in movement formula, we required force. So we will convert this mass into force. How? We will apply this formula. We will make this mass as weight and weight is a force. So this will become G is 9.8. Whatever the answer is, now this force is basically the weight. Tell me the answer. And they are saying it is 2 meters from the pivot point.
Okay, just a second.
What's the
It's
answer?
0.196.
So now I have a force that is acting in the center, which is 0.196. And if I want to find out the moment now, so moment will be equals to 0.196 multiplied by 2. Clear? So that will be the moment. And the unit of moment is Newton meter. Tell me the answer.
It's 0.392.
Did you get it?
Yes.
Okay. Then the conditions for center of gravity. An object is highly stable if the center of gravity is down to earth. Like for suppose I have two objects. This is ground, and on the same ground this object is kept. This is the center of gravity and this is the center of gravity. Check it out, the arrow. This arrow has been raised from the ground and this arrow is down to the ground. The lower the center of gravity is, the stable the object is. Like this car. This car is highly stable, okay? Because its center of gravity is lower to the ground. And here the center of gravity is very high, okay? Also, the base area must be wide. This area must be wide. So what are the conditions of stability? The center of gravity, COG, will be low and base area must be wide. Okay?
Yes.
Did you get it?
Yeah.
Like the question, if it is asking this question, this and this, which one is more stable, A or B?
It's B.
It's
B.
B. Okay? Okay, when we are talking about pressure, always remember that when they ask the question why the liquid flows, for suppose wherever the liquid is flowing, why the liquid is flowing. So you'll write it is because of gravity. For suppose if I'm saying that this is a beaker and when the tube is inverted, the water starts flowing into the beaker. So when they are asking why the liquid flows or why the water starts flowing into the beaker, so the answer is this is because of gravity which is pulling the liquid down, or the pressure difference. It has
Yeah,
high
yeah.
pressure. Sorry.
Yeah, I can hear you.
And the force is different. So this is your answer. Okay. Pressure always increases with the depth. Why it is increasing with the depth? Because at the depth, the gravitational field strength increases and the molecular concentration increases. This type of question always come for 2 marks. So these are the two reasons. Okay.
Yes, okay.
Then we have pressure in gases. This question is asked frequently, that for suppose if I have a syringe and this syringe contains gas molecules, okay?
Yes.
How these gas molecules are exerting pressure inside the syringe. So these are the reasons. The gas particles
Can
are
I
continuously...
rejoin?
Why?
Because someone called me and now the voice is a little gone. I'll just rejoin very quickly.
Okay, actually, we are about to finish the class.
Because the voice is very low.
Okay, rejoin quickly.
Okay.
Is it fine?
Yes.
Okay, what I was saying, that if it is asked that how the pressure is created inside the syringe, this is the reason. The gas particles are continuously colliding with the wall that are creating force per unit area, and that's how the pressure creates. Okay.
Yes.
But what if I increase or decrease the piston in the syringe? What will happen then? That is Boyle's law. If you increase or decrease the volume, what will happen? If the volume is decreased, that means if the piston is lowered like this, the space reduces, space between the particles reduces, collision increases, or you will write collision will be more frequent. You will use this word, okay? And that's how the pressure will increase. Also, the kinetic energy will increase. Clear?
Yes.
These are the keywords that you are supposed to write down when the volume is increased or decreased. Clear?
Yes.
And that's why the pressure and volume are inversely related to each other. So if you are raising the pressure 2 times, the volume will be reduced 2 times. If you are raising the pressure 3 times, the volume will be reduced 3 times. Clear?
Okay.
And lastly, we have how pressure and temperature are linked. When you increase the temperature, kinetic energy increases, collision will be more, and pressure will be increased. So these are the keywords that you need to remember. Okay.
Yes.
Okay, let's keep it up till here. I'll do the recap of work, power, energy onwards in the next class. Okay.
Okay.
Okay. It could be possible that next class could be lengthy, more than like 1 hour. Will it be fine for you?
Tomorrow, yeah, it's fine.
Okay, so I'll take your class at the same time, that is 5 p.m. So KSA time, okay?
Okay. At 7?
Okay. 5 p.m.
Okay.
the same time, okay? Take care,
Okay.
bye.
Okay, bye.